Hello everyone, this is Neelima, Patnla. I did my bachelor's from Visakhapatnam, master's from IIIT Hyderabad, and PhD from IIIT Hyderabad in the area of earthquake engineering. So I am an assistant professor at Institute of Aeronautical Engineering at present. So today we are going to learn about Introduction to Geology, a topic which is very important for civil engineers, and we are going to learn about how geology is actually important for civil engineers, and what are the different branches of geology that are very important for our studies. So let us start with the discussion about geology. So geology, what is geology? Geology is about science of earth, which deals with origin, age, interior structure and history. And it also deals about the evolution and modification of surface features and minerals in earth. So this picture depicts that the topographical features of the complete globe, so which is given by National Centers for Environmental Information, Information. So we can see there are many branches of geology, which are physical geology, mineralogy, petrology, structural geology, historical geology, economic geology, paleontology, and engineering geology, mining geology, geophysics, geohydrology, and geochemistry. There might be some more branches which are subsets of these. So let us deal about each one in detail a bit more. So physical geology. So physical geology deals with physical features of Earth and natural phenomena like earthquakes and volcanoes. So they discuss about the topographical features, like physical features in the sense topographical features. Then coming to the mineralogy, the name itself suggests that the study of minerals. It is the study of minerals, which is the basic unit of rocks. Now coming to petrology. Petrology is about rock materials. So the formation of rocks and how they evolve during the geological time scales, and the texture that is actually there with all the rocks, and then composition of rocks, occurrence of rocks, and different types of rocks, and how they are related with the current geological features of the earth. Then coming to structural geology, which is very, very important for a civil engineer, because most of the structures are on the ground where these are going to get affected directly by these studies which are conducted as part of structural geology. So structural geology deals with geological structures like folds, faults, joints, and conformities. So something like if there is a fault in a particular area, then we're not going to construct any building or any structural engineering aspect there. So we need to know where they are there and how much extent they are there, and what is the probable earthquake that is going to come from that particular area. So what is the future earthquake? So we need those predictions, and for which we also need the history of that particular area and the fault and the maximum amount of earthquake or magnitude of earthquake that it can produce. It is capable of. It is more like a capable of producing it. Now coming to historical geology. These branches are not quite different from each other, but this historical geology is about, it is also called stratigraphy, and this is about estimating the history of a particular area or the rock through sedimentary rocks in the sense that they are the name itself suggests that they are the sediments which were deposited during different geological processes. So this study, depending on those sedimentary rocks, when they have formed, how they have formed, and what made them settle there. So all these parameters will suggest us what is the age of a particular thing, particular area, and how it is going to transform itself in the future. So these all things are important for our constructions to have. We have to decide the constructions to present in a particular location. Then coming to paleontology. Paleontology is about understanding the ancient life through fossils. What are fossils? Can we understand fossils a bit more? So we have this animal parts and plant parts which are sedimented in a rock, inside a rock. So they are called fossils. So by using that, we can get the understanding of a particular area when it has formed. What might be the formation age of a particular area, and then how young it is, how it is going to affect. I can give a small example for this. So we can also think that, suppose fossils are similar in two different regions. What it suggests? It suggests that these two regions are, once upon a time they were together and today they got apart. So this is a typical example for the tectonic plate movement that is actually suggested by Wegener. So which was the formation, I mean, which was the basis for all the earthquakes, I mean, all the reasoning that we give today for earthquakes. Then coming to economic geology, it is completely the commercial part of geology, which actually is important, is definitely important for understanding the formation and availability of certain kinds of minerals, which are important, which are economically important, such as graphite, talc, mica, asbestos, gypsum, magnesite, barytes, diamonds, and gems. So these are also important, and they are, I mean, they directly give an I mean indication of the wealth of the country. Then coming to engineering geology, we are well important, well versed, and well appreciated for civil engineering community is engineering geology, which deals with the application of geological knowledge of civil engineering for safety of constructions. So the target here is the safety of constructions. So whether the soil which is present on which I'm going to put my construction is going to hold the structure or not. There are conditions, there are cases where the soil failed and the structure is completely intact. So we need to know whether the soil is capable enough to carry the construction material that is present in a particular area. So which will be answered mostly by the engineering geologists. Then coming to mining geology, which is the application of geological knowledge in mining industry. So where we have to dig, where we have to extract ores, where do we find certain metals. So that is what is called mining geology. Then coming to geophysics. This geophysics is the study of physical properties of the, like, properties of a particular area, like density and magnetism of earth. Why do we need magnetism of earth? Because we need to know what is present in the crust. So we can see here two types can be classified, like pure geophysics and applied geophysics. What we are concerned about is the exploration geophysics, which is the applied geophysics. Why do we need applied geophysics? It is because it deals with the upper layers of crust to solve construction issues. So the upper layers of the crust, how things are changing, what is the different layers that are present in the upper layers of crust. So because of which, whether my earthquake waves or my vibrations that are happening, which different causes, not only earthquakes, we have different vibrations. So there might be a blast because of tunnel. So are these vibrations, how are they going inside the earth and coming out? They are reflecting, they are refracting. So all these processes have to be understood in detail. So geophysics actually deals about this study where it understands only the upper layers of crust, right? Then locate construction issues and locate oil and gas deposits. So oil and gas deposits, whether they are available or not. So my offshore engineering completely, which civil engineers deal, is completely dependent on this availability of oil and gas deposits. Then locate groundwater table. So my constructions or the civilization where it has to grow. So it is much better, it is much economical to grow my civilization from a town planning perspective, to put it at a place where groundwater table is high. So I get a lot of groundwater reserve. So definitely I need to know what is the groundwater distribution among a particular, I mean, in a particular area. Then coming to geohydrology, which is name itself says that the hydrogeology, which also deals with the groundwater availability and how it is moving, whether it is depleting or whether it is increasing, and what measures we can do to increase it. So all these things will be dealt with geohydrology or hydrogeology. Then coming to the last one, which is very new science, which is geochemistry, which deals with occurrence, distribution, and abundance and mobility of different chemicals in the crust. So what are we going to with this different chemicals? So how is our earth getting contaminated? Do we have to invest some time into soil conservation or not? Or do we have to strengthen our soil such that we can place our construction material or not? We can carry out our construction or not? So these are all the branches of geology. Now let us discuss about what geology or how it is important for civil engineers. Now, the most important aspect of geology is that we need our raw material for construction. So the natural construction material has to be abundant. Now, required for the construction, such as foundation rock, we need, and what kind of rock it is, and how strong it is, what are the different parameters or properties that are there for the rock, such that what kind of constructions can be made there. In certain locations, we can rely on the rock and then we can make a tall building. But at certain locations where soil is very loose, we cannot think of constructing something, or it might also possible that we can go for a small low rise building rather than a tall building. Then coming to road metal. So whether we get the metal or not, like steel is available or not at a particular location, steel can we get it locally or not. Then we have concrete aggregate, which is the direct byproduct, direct product of the rock. The crushing of rock, we get the aggregate, both the fine aggregate as well as the coarse aggregate. So we have quarries or not nearby, and then what kind of rock we get. So we can't add some talcum rock, such that there are certain properties that are required for the concrete to build. So all those parameters or all those properties are required. So whether we are finding a rock of such type or not. And then we have building stones, whether we're getting of that size or not. Then roofing material. So all these things we need. And what geology does is that it gives the study of materials, their structure, properties, and occurrences. So where they are found and how they will be available, and what are the parameters or what are the properties that are present for a particular kind of rock, such that once we get that information, then we can focus on the construction, what kind of construction we can make in a particular area. Then coming to the next important aspect of geology in civil engineering is the selection of a particular site. We need to know different geological features that are there in a particular area. So we have, suppose we have a type of, we take type of construction. So what type of constructions can be made at different locations. So for a particular dam, suppose we take it as a dam, and we can take example of a dam. Dams are constructed at locations where streams have narrow channels. So we have to, what is the main purpose of dam is that we need to make a reservoir about it. So we want the water to be held there. So for which we need to focus on where the stream is narrow, right? So we need to know that aerial view of a particular area, and then can the water be stagnated there or not. So all these things will be answered by geologists. Then coming to economical. So we require lesser cost of excavation or cutting. So how much area is there in a hill? Okay, whether how much it has to be cut, how much it has to be excavated. Can happen in certain locations. So the figure shows there, like ground at places it has to be cut and it has to be filled at another location for making the ground stable, or by making the ground on a single path. So that is another reason. And then we have availability of local material. We have decided in a particular area, so we are going to construct something. So in this particular area, is there the availability of local material here? Because there's a huge pressure or huge increase in cost of the construction if we are going to transport it from some other location. So we need to understand whether locally this construction material is available or not. So that is also important. So all these answers have to be made by geologists. Then coming to susceptibility to geological hazards. So we need to know, now we are building civilizations. Now we are we are building our colonies around rivers. In olden days, it used to be like that. All colonies grow just beside lakes and all. Now, do we have those water sources or not? Are they depleting, or are they they're still there? So all those things have to be answered. Then coming to very important aspect is that earthquake prone areas. So earthquake prone areas, are we living in them or not? Because it's always important to understand the earthquake hazard that is present in a particular area. So if you consider, for an example, if we consider the northeastern area in the country is completely full of earthquakes. It is expected to have higher earthquakes than compared to the southern part of the country. So, how far we are going to build and what kind of constructions have to happen that at that location is all town planner or architect has to decide so whether we're going for such buildings in that locations or not. So another important aspect is the seismic gaps that are present in a particular area. Seismic gap is nothing but uh, for a certain amount of time, certain time period, there is no earthquake that has happened. We all know earthquake is a stress build-up process. So it takes a lot of time to get an earthquake. So one earthquake happened and another earthquake should happen after a considerable amount of stress build up. So in this condition, then if a lot of time span is there between two earthquakes, that area is called seismic gap. That means it is possible that in that area a higher magnitude earthquake is expected anytime after certain duration. So this area is highly probable to earthquakes and sudden shakings. So in that area, it is important to understand whether the area under consideration is the seismic gap area or not. So with that decision, we will be able to understand what is the kind of constructions that should happen in that location. So what kind of constructions can happen, what kind of construction should not happen, and can there be some possibility to, I mean, resist or withstand that shaking or not. So all these decisions can be made if we get the information about the local geology. Then coming to land side susceptibility. So this is the direct geological feature that we can see directly. So the recent Joshimath issue, which is Joshimath subsidence, which is actually the most important and alarming thing, is that the land subsidence. So the land side susceptibility, if we are well aware of it, so we will be cautious to understand, or we will be cautious in building our civilizations there or building our colonies there. So the expected at hills with steep slopes present in earthquake prone areas. So that's a worst combination. It's a very steep slope. Anyways, it is going to subside. And then it is present in an earthquake prone area where a small shaking can make the sliding happen. Then stability of slopes. No, if we are not constructing, is there any hill nearby? So if there is any hill nearby, that debris is also going to fall on this. So all these parameters have to be considered. Then we have choice of material depends on weathering effects expected at a site. So the kind of material that we have to use in construction is depends on the weathering effect. So if there is, I mean, if it is a very very cold place and a rainy place, then we are not going to use the wood because it is going to damage the construction. So these weathering effects, what will be present in a particular area, so all these parameters will help us in understanding and finalizing the material that we have to use in the construction and the area whether we have to present them or not. So all these things will be helpful. I mean, the information that is coming from geologists will always help in understanding the actual construction industry. Then coming to explorations of groundwater table. It is necessary for excavation and water supply. So as we have already discussed, in a particular area, whether to have civilization or not, this depends on the area. I mean, this depends on the availability of groundwater table or the surface waters that are available nearby. Then we have conservation of natural resources. Are we going to conserve? I mean, can we help the natural resources not deplete? So soil conservation, we can make some soil conservation in a particular area. And then river control, we can control the river to divert or to withhold in one area and then flow to another area. So this river control can happen, and all the coastal works and harbor works can be sorted out with the information of geology. Whatever geological features that are present and the topographical features that are there in a particular area can help us in doing all this conservation of natural resources. So these are the references, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.